Hello guys, welcome to my channel called Doctor, and today we're going to solve a problem called alien dictionary. So this problem is really important, so, because in this problem we're going to learn multiple data structures and also there are different algorithms. Now just read the problem statement. So what problem statement says is there's an alien language, right, that uses some English alphabet. Okay, that means it uses characters from A to Z. However, the order among letters are known to you, right? You don't know the order. What's the order of the letters? So like say if I talk about English dictionary, then we know the order, right? So what's the order? We say A, then B, then C, and then Z, right? So A should come before B and B should come before C, right? Like this. So this is the English dictionary. Now this is what we're working on, alien dictionary. In alien dictionary, we don't know the order, right? So we want to come up with a order in this, and what we have given a list of words from the dictionary where words are sorted lexicographically according to the new rule in this language. So now if you see, let me give you an example. Let's say we have apple, we have ball, we have cat, right? So in this I will just look into the first one because the words are sorted, right? They're telling about the words, right? So apple, so from this two words, what I will say, I can deduce from apple and ball, right? If I just look at this, I can say that, so what I will say, I can say that A should come before B. And if I look these two, right? So what I can deduce, so I can say like B should come before C. This is this is English dictionary. Now, similarly, if you talk about alien dictionary, so if I say WRT and WRF, right? So what you will say about these two words? Let's see. So you will say the T should come before F. And let's say now we have this. Then you compare this, right? So this is like a sorting, right? So you will look for the first characters first, or you will start from the first character in the corresponding word, and you will stop when you find the unmatched corresponding character. So if you see W and E, yes, so you can see W should come before E. Next one, E and R. So what do you say? So you will say E and E are E and E are same, then you can deduce that R should come before T. Similarly, if you look for the last one, right? So what do you say? E should come before R, right? Now the question is like why you are not comparing like after E, right? So because this is just lexicographically sorted according to the alien dictionary, like alien order, right? Which we're trying to find. So once you sort, right? Once you do the sorting, you just sort. You're sorting this word based on the first unmatched, right? Because there is the order decided. That's why you do the sorting. So you're just comparing the corresponding words in a list of words, and you will stop when you find the corresponding unmatched character. And that's where you find an order. Okay. Now this is something really interesting. Now, now the question is like, how did you find like what kind of data structure that we can visualize uh, with this pattern, right? We have different characters, and there is some relation, right? So whenever I think of like there is some input and we're looking for some relations among them, then I try to think about directed graph, right? So you can see like T is one of the node, right? And F is another node, and T has a edge pointing to F, right? Similarly, W has a node. W is a node which has an edge pointing to an E. right? So this is a kind of a graph. Let me just plot something on JS Paint. Okay, so if you see, we have T, then we have F, so there is an edge to it. Okay, then you say you have W to E, so you can say W, you can say E. Okay, next is R to T, so you have R and you have a T. What next? You have E to R, you have E and then you have R, right? So this is some directed graph which you can find. Now if you tell me like what's the order, right? So like W should come before E, and E should come before R, and R should come before T, and T should come before F. So that is W E R T F, and that's the order, right? So if you think about this, can you see like there is some traversal happening from one node to another node, right? Now if you think about this, like we are starting from one node, then we're going to another node. So this is some sort of BFS traversal, right? BFS traversal, and there's a directed graph. Okay, so just listen the points. Like we know there is a BFS, and before that we know that there is a directed graph. Okay, what next? Okay, so now there can be a cases when you have, like, say there can be a edge where R should point to F, right? So that means uh, R should come before F. So you cannot process F until you process R, right? So you need to make sure, like, you try to process the node once the integrity of those nodes, right, should become 0, right? Then only you have to process. You understand this, right? Clearly. Okay, so you need some kind of integrity. So this is a kind of a helper, right, for us to actually take us into the right direction, because otherwise what will happen, like when you, because we need to think about all the possibilities, because right now the example which they have given doesn't contain multiple edge into the node, right? But there are possibilities. So if that's the case, then you have to make sure that you process R before F, right? Before F, right? So F should be processed in the last. You have to make sure. Okay, so whenever we have this thing, right, when we have to process the node before processing like other nodes which are pointing to it, you have to think about in degree. So that is the insight which has to be deduced by trying out, by building this graph in an example. Okay, perfect. Now you can see some other example. We have a z and x. This is very straightforward. Z should come before x. Then you have z and x and z. So in this, what happened, you say z should be before x and x should be before z, right? So that creates some confusion, right, altogether. So it means the order should be invalid, because you don't know in an alien order what should come before and what should come after. So this is one of the corner case that you might need to handle. Okay, so I can remove this, and first thing, like, I need to have a graph. So how you define graph in Python? You will say collections dot default dict, you can say list, right? Because in graph you have a node, and you have, from that node you can have list of uh, like list of nodes that you can point to it. Multiple edges are possible, so that's where the list comes into picture. Now after the graph you need an in degree, right? now now you can see like what should be the in degree for you, right? So in degree will be, we need to initialize for all the characters because these are the nodes. So before building the in degree, we need to know what we need to, before building the in degree, we need to initialize the in degree, right? Okay, so before initializing, like, we need all the unique characters from this list of words. What we can do is we can get all the characters by simply doing mm, 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 mm. Okay, I think you can do a set, right? Set, and then you can join all the words. I think that should be enough. Let's print it out. So it's always good to just keep debugging while you're writing the code, so you know, like, your code should compile all the way and you're going in the right direction. So collection, it should be collections. Okay, right. So we have got the set. Perfect. Now from this set I can build an integrity, right? So first I can do like integrity should be, and I can have a character map to initialize to 0 for ch in cats, right? Very simple. Let's print this integrity. You can see like we have r map to 0, e map to 0. Very simple, right? Now what is the next thing? Now we know like we need to build a graph, right? And how we can build the graph, as you can see, like while doing the example, we know like we have to iterate through the corresponding words. So that means we need to iterate through this list for I in range of this length of, let's do word minus 1, because we need to compare the corresponding words. We need to pick like 2 words. That means like word 1 should be like words of I, and word 2 should be like words of I plus 1. Perfect. Now if you know like how to iterate in Python, like corresponding words, there is one really nice syntax. So this is like you can do the zip of word 1 and word 2, right? So what does it mean? Basically, let me just give you an example for this. So let's say you have A B C, and then you have E F G, right? So when you try to zip these two, your output will be a list of tuples. So that will be like A comma E comma, you will have B comma F, right? Like this. So you know, right, corresponding alphabets. So it's very easy to iterate. So when you do this, you know like this X and Y points to A and E, and if you just take an example of WRT WRF, that will be W and W. Now coming to this, let me just give you one more edge case. Let's say you have ABC and AB, right? If you are given this input, so what you will do, right? So whenever we have this case, you can see like this AB and ABC. If this is the order, that means you don't have the character, you don't have a character for C to match in the word 2, right? Or the corresponding character. uh, so you cannot deduce an order for C, right? You cannot deduce an order like where it should be in the alien order, right? If this is the input given, right? So that means you need to handle this, which is if the length of this word is it's greater than this, you should return. If it's happening anywhere in between, you should return the empty string, right? Which is invalid order. We'll see that. Okay, so now we are here. So if x is not equals to y, right? Because then only we can find an order, right? Because that's the character, because based on that only the words are sorted. So you need to build a graph. So how you will do that? You will say graph of x dot append y, right? And you will update the integrity also here. So integrity of y increase by 1, and then you will break, right? Because you don't have to go further, because that is the character, based on that the sorting happens. Now there's something interesting syntax I want to tell you guys, which is for and else. So what does it mean, for and else? Let me just give you a basic example for the syntax. So you have like for I in range You will say from 0 to 2, and you will say print I, then you say else, and then you will say print done. Right, so what should the output of this? So output will be like 0, 1, and it will say done. So that means else will execute once the entire for loop completes. Okay, so because we want to handle the case which we discussed, ABC and AB, where we cannot able to find uh, any corresponding what is it, the character for C, right? So here you should say if the length of word 1 is greater length of word 2, you can return empty, right? Yeah, so now after this you can know, like, you will have a graph. Let's print this graph and also print in degree. So you can see the graph, u map to t, e map to r, so you can see t map to u, t map to f, and w map to e. This is the graph which we actually uh, which we like accept this node, right? So this is the graph we built. We get this here, and similarly we also get the in degree. You can see the w has in degree of 0 because w doesn't have, except all of them get 1, which is right. Now we know, like, we need to start from the node where we have in degree 0. So, and then we need to do some BFS. So for that BFS we need a queue, right? So we need a queue, and we need to find the node to start with. So let's iterate inside key value pair inside in degree dot items. Okay, so we need to look for, if the value is 0, there you can do q dot append your key. So key will be the character, right? That's what we're looking at. Now we want to do BFS. Let's say we have a result string which we want to return. Now how we will do BFS? We'll start like a queue. If the queue is not empty, first of all you will get the node, right? So that node will be, let's say, a character. Now that should be like q dot pop from the front, so that's why 0. And then you can take that and append to your result, right? Then, so how you do the BFS, right? You first take the node, then try to explore all the neighbors, right? So you know you need to go through all the neighbor in graph of that char, right? So if you have a confusion, it's better let's use the word node so you can understand the code semantically. Now when we are iterating this for all the neighbors, right, we need to append that neighbor to the queue, right? But before that, when you need to append, you can only append to, you see what does it mean to append to this queue is, like, you will process that node next. So when you can process a node next, only if once the in degree becomes 0, right? So you will update the in degree of that first neighbor. In d of neighbor you will decrease by 1, and then you are going to compare the in degree of neighbor. If it is 0, right, then only you will append that neighbor to process, and you will also, yeah, you should not do anything. Yeah, I think that's it. Very simple. You just append to neighbor to the queue, and then you will keep doing BFS. Now I'll just return the result now, and let's see. Yeah, so it's correct, right? Our output is exactly what is expected. Now let's run on this. See the magic. Boom, it's gonna oh it's correct, right? what is expected, and this is fine. Okay, so now think about, is there anything else we are missing? We don't know. Okay, let's submit and see what happened. Something is failing, right? Something is failing badly. So what can be the issue? So one thing is, so output is this, but expected is this. So what is happening here? Okay, so we got expected would be something and we're getting a. From where this a comes into picture? Okay, let's do this. Let's run this. Okay, output is this and expected, so this is fine. Okay, so why it says wrong, I don't know. Let's run it. Okay, oh, weirdly it code. Okay, but this is correct, like this is supposed to fail because our output is b, expected was this, because we cannot deduce any relation, right? If you see a and z, right, a and z, so a should come before z and z should come before z. But what about b, right? What about b? So b is here only, but b will come before x, right? So yes, let's take this test case and we'll try to run it. Okay, so obviously it should fail. So something is we have to note in the output, right? So you see, like we're just getting b, so that's what happening is when we do the bfs, we don't know where to go from the node b, because b has in degree 0, that's where we have to start, but we don't have any other node, right? So graph is some sort of disconnected, or maybe, yeah, it's kind of disconnected graph. So what you need to do is you need to add a check. So if the result, so there is a hack to it, what I can do is I can just do like of set of result. If I do the set of result, right, and this should be equals to the characters, right? So the output should have the same set of characters which we have all the unique characters, right, in the list of words. So that means now this will return true and false, right? So if it is true, it's 1, it returns. So this 1 is like true, is multiplied by a result, you will get you will actually get true, but you will get the result which is like a string. But if it is false, then multiplying by result is actually return you an empty string. So let's run this and see what happened. Wow, it works. Now let's run for all the test cases. Boom. So yeah, it worked. So if somebody asks you what is the time complexity for this, so I can say like we are just iterating through each character in the given list of words. So the time complexity will be big O of, you can say the time complexity will be big O of, so list of words, we can say the length of words multiplied by the average length of word, right? Average length of word, and that will be like n square kind of thing. And somebody asks you a space. Now this is very tricky. Now space, as you see, we are creating a graph that only contains the nodes, right? That maximum contain the nodes of all the characters. Now we know this contains only English alphabets, so it's gonna have maximum of 26 characters. And similarly for the set, it's going to have 26 characters. Similarly for the in degree, right? So the complexity, space complexity will be big O of, we can say 26, that is like constant. Yeah, Perfect. So I can just save for my purpose. Let's save it. Perfect. So now you know, like, these kind of problems are really tricky initially, but once you start uh, like drawing graph around it and understand, like, you have to do some traversal, and you deduce, like, you have to do the BFS, and you have to make sure something, the node has to be processed. Once you process, like, all the nodes which has a dependency to it, so that means some in degree. So once you know, like, these kind of small helper like algorithms or data structures before you start implementing this, the problem seems to be really simple. I think, let me know in comments, like, if you have any doubts about this. I will definitely try to help you out. And it's a really important problem because I can see myself, like, getting this question in interview in Microsoft and Amazon. uh, so this is really important for SD2. Thank you guys, thanks for watching.